Okay, you guys you already reminded me that you remember a lot of stuff about this right triangle trig. So hopefully you remember that. All right triangles have a 90-degree angle, and the three special ratios can be written using the lengths of the sides. We're going to start with the tangent ratio. Tangent of an angle is in a right triangle is the opposite leg to the angle compared to the adjacent leg to the angle. It's usually written opposite leg over adjacent leg. The hypotenuse is not used for tangent ratios at all. Okay, so if you want to do the tangent of angle A, you go over to angle A, and it's like this is where you're looking from. So I made a little eyeball. From angle A, the side opposite would be the 4. The side adjacent would be the 3. So this opposite over adjacent would be 4/3. I don't know what that blank is for, since 4/3, oh, unless you wanted to write it as a decimal, 1.3 repeating. Tangent of W, you go look and say, well, I got to start at the W, so it's like you're looking from there now. So from there, opposite, I'm teaching this in geometry too, and a lot of kids don't know it yet at all, so I'm kind of explaining it a little bit like that at first. The opposite, this would be your opposite leg to that angle W, and this would be next to it, adjacent. And you might say, well, 13 is next to it too, but it's specifically the hypotenuse, and we're not using it. So that'd be 5/12. And if you divide that out on your calculator, 5 divided by 12 is point something. Is it a repeating decimal? Then you put 1.16 with a bar over it. 0.4, sorry, 0.416 with a bar over it. Okay, then on the next one, tangent of T, coming from T, if you're looking from there, the side opposite would be the 8, the side adjacent would be the 15. So tangent of T would be 8/15. And that's, I don't know, 8 divided by 15. Okay? No. Okay, so what you're asking me then is at the end of the calculator, no, it wouldn't be 4 because it's rounding. Okay, all right, so I'll tell you. This won't round at the end because 3 is not bigger than 5 or larger. So at the end of the calculator, it'll stay a 3. Okay, but when you have 0.16 and you keep going with the 6's, at the very end of the calculator screen, it's going to round to 7 because it still repeats 6's forever. It's just that your calculator can only show so many places, so it rounds it up at the end. Okay? You just want to show what part repeats if it's a repeating decimal. Okay, write the tangent ratio for each labeled as a single fraction. Do not solve. Okay, so we're just going to set these up. The tangent of 41, the angles, you're always looking at the acute angle that you're given, would be x/14. From number 5, you go to the acute angle. You never start at the right angle. And then you're looking out at the 71, and the opposite that would be the 20. So the tangent of 71 would be 20/x. For number 6, you're looking from the 42 degrees angle out, and that would be tan 42 is x/16. Is anybody not sure how I'm getting these set up? If you are, I'll explain more, but if not, I want to try to just continue since you're familiar with this. You may not need me to say a whole lot today. Okay, so all tangent ratios for a particular size angle are the same. In other words, any right triangle that has a 42 degree angle is actually similar to another right triangle with a 42 degree angle. So they all have the same tangent ratio. All these answers are in the calculator. It's been programmed to be able to do the ratios given the angles. Make sure the mode on your calculator is in degree. So you might start getting some wrong answers here if you haven't checked your calculator. So everybody needs to go and double check. I've already done that today, but if you would go to mode, please, you might have a calculator, especially if you borrowed one that's not in the right mode. Okay, so mode is needs to be, well, put it in normal, not scientific. You don't want it in scientific notation. Put it on float so you get all the decimals. Okay, you can actually tell your calculator round things for you, by the way, by putting it on how many places you want. You don't want it to be on radians. So if your calculator is highlighted on dark right here on radians, you need to change it to degrees. Does anybody have that happening? Because that could definitely happen. You do? Okay, so just arrow down to it. So if it looks like this right now, you need to turn on degrees by arrowing to the right and hitting enter. Okay? Always make sure it's in degrees for this until I tell you otherwise in the unit. You always want it in degrees. Okay, now we're going to type the tangent of 60 and we're going to go to the 3 decimal places. So hit tan 60 and I will explain to you after we get all these what they mean. I just hit cosine. I don't know why. Tan 60 accidentally hit cosine instead of tangent. All right, tan 60 is 1.732. Okay, keep going. Tan of 32, and you guys want to just tell me because it will be a little faster. 0.625. Okay. Actually, I've got them all written down, so I'll just go to that page. I think I do. Yeah. The next one should be 0.268, and the last one 8614.301. I do not remember being told what these numbers actually mean. And when I was in high school and did my first trig class, it was called Trig Analytic Geometry, like pre-calculus here. That's the new name. But anyway, I thought I would discuss with you what these mean as decimals. Does anybody know what they mean? I kind of don't think your teacher may have told you when you learned this before what they mean. We're comparing two sides. What are we comparing? Yeah, we're comparing the legs. And specifically, we're comparing the length of the opposite leg to the adjacent leg in that triangle. So, what they mean is this means that the opposite leg to the 60 is 1.7 times as big as the adjacent leg, or 173% of the adjacent leg. This one means that the opposite leg to the 32 would be only 62.5% of the adjacent leg, meaning it's smaller. So if the number is bigger than 1, then the opposite leg is bigger. If the number is smaller than 1, then the opposite leg is smaller than the adjacent leg. Now look at this one. Why is this so dramatic? That's because if you had a right triangle with a 90-degree angle and an 86-degree angle, it would look something like that, because the opposite leg to the 86-degree angle would be about 14.3 times as big as this one. Okay, that's why. All right, so anyway, just thought you might want to know what the numbers mean, and then you kind of get an idea what the triangles look like. Write the tangent ratios for each pair of angles and leave as reduced fractions. Okay, we don't need the calculator right now, so let's just pay attention and start writing these. Tangent of x and y. Well, if you're coming from x, then you're looking from here, and it would be opposite over adjacent. I'm not writing on them because I get 3 over 3, and then because I'm going to come from the y value, I'm now coming from over here and looking out, and I see 3 over 3 also. Well, these both give me 1. Tangent of x is 1, tangent of y is 1. And what kind of triangle must this be? They're all right triangles. They have to be right triangles to do right triangle trig. So let's try something else. What kind? It's isosceles, so what's the angle measures? They're equal, right? How big are they? Okay, you hopefully will remember this special right triangle pattern, 45, 45, 90. Okay, and that the sides are n and n, and the hypotenuse is n times the square root of 2. You're going to be using that a lot in this chapter, okay, this unit. We're going to need to know this one, like, bang, 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 really well. Okay, so let's go over here. This one is no special one, okay? We're just going to write the tangent of g, so we're looking from here. Opposite, 8 over adjacent, 8/16, and then we should reduce that to 1/2. And the tangent of t, we're coming up from this angle now. The opposite leg would be 16, the adjacent leg would be the 8, and we get 2. Now this one's no special triangle either. Tangent of p, coming from up here, that's 7/24. You don't use the hypotenuse, and the tangent acute would be coming from here, so you're doing 24 over 7. They're reciprocals of one another. Any questions there about how I got those answers? Okay, we're good? Next page. Now we're going to write an equation and we're going to solve it. Okay, write the tangent equation using the labeled angle for each figure. And solve. Round your answer to the nearest 10. Alright, so we always want to go to the acute angle, never the right angle. So then it's like we're standing right here and we're looking. Okay, so whatever, eyeball. So we look in and we see opposite, adjacent. This would be your opposite leg. This would be your adjacent leg. So this is a tangent of 30 is equal to x over 100. I want to see your setup. I do not want to see what you typed on a calculator. I'll know if you typed it wrong or not. But you can set it up like a ratio or proportion. Right, a ratio by writing 1 and a tangent of 30. Then you have a proportion problem. Cross products are equals. This is what we're doing. So 1x is equal to 100 times the tangent of 30. And you may have remembered how to calculate these. And that's all you got to do is type that on your calculator. 100. You don't have to hit times. You can just hit tan 30. And then hit enter. That's 57.7. What did it say to go to? Round your answer to the nearest decimal. Okay, first one place. So 57.3. Is that what it was? 57.7. All right, so number 15. If we are looking from here, the opposite leg would be the x, the adjacent would be the 18. So that's going to be the tangent of 70 is x over 18. That would be x equals 18 times the tangent of 70. Okay, 18 tan 70. $49.5. Was that, did I round that correctly? Yes, okay. Then the next one, you're coming from the 55, you got your opposite leg and your adjacent leg. Same problem, except x is in the denominator, so you got to be careful about how you calculate that one. 4 over x, treat it like a proportion. So now we're going to have cross products are going to give you something different than the last two. We're going to have x times the tangent of 55 equals 4. And then you need to divide both sides by the tangent of 55. I won't write it like this every time, but I am right now. Okay, so what we need to do is type 4 divided by tan 55. And you should have 2.8. And that should be in centimeters since that one's labeled. 17 is similar in that we have to start with the 28 degrees, and the opposite leg would be the 10, and the adjacent leg would be the x. So we've got x times the tangent of 28 equals 10. We'll do 10 divided by tan 28. Those are probably the only ones that most students usually have trouble with. 18.8, because they might have assumed that every time the x is on top, and it's not. And that's in yards. Okay, go ahead and do those next two, and I'll tell you what the answers were. How many of you already did 18 and 19? I'm just checking. Okay, thank you. Hey, Kai, hate to bore you, but you can't sleep. Wake up. Tan 58 equals 15 over x. Let's get it done. Okay, so I want to know if you know what you're doing there, so let's open a calculator and calculate this, please. Should have 9.4, guys. Are we okay? If you made a mistake, tell me, because I want to clarify or make sure you're doing it right. Okay, you should have had your setup For 19, tan 25 equals x over 15, and you should have gotten x is 7.0 meters. And this last one was meters as well. Okay, let's see if we can do this flagpole problem. Person standing 30 feet from a flagpole can see the top of the pole at a 35-degree angle of elevation. This is an angle of elevation. You will need to know what an angle of elevation or depression is. You remember the Z in geometry? Going from a horizontal down, that's an angle of depression. And then when going from a horizontal opening upward is an angle of elevation. Got to remember that from geo. So you'll know how to do the word problems that you're assigned this evening. Write a label diagram with 30 feet and X for the height and correct places. Okay, so I've got person standing 30 feet from a flagpole. They've already shown me where the angle is. This must be my flagpole, and I want to know how tall it is. So that must be my X. And then he's standing 30 feet from the base. He's not in the air or away from the flag. So we put that on the ground, please. Okay, you can see why it wouldn't be on the hypotenuse, because that's just in the air. There's no string or something. All right, so this would be the tangent of 35 equals x over 30. And just calculate 30 times the tangent of 35. Oh. Okay, I got 21. Okay, so the flagpole is 21 feet tall. Good? All right, we're going on to more trig ratios. Ready, set, here they come. Now, you guys said, most of you have heard and know, and that's because lots of teachers use SOHCAHTOA. Did they tell you the story about the Indian princess, where it came from? Okay, well, I'm not going to either because I don't really know it. So I'm going to tell you, oh, I've heard about the story, but I just don't know all the parts, and I don't know it well enough to tell because I don't use it. So I use, Oscar has a heap, and you can use this or not, of apples. You can make up your own if you want. Like you could do, Oprah has a heap of annuities. Joking. Oscar has, that's on your calculator, it's the first one. Sine of an angle, cosine of an angle, second one on your calc is adjacent over hypotenuse, a heap, and tangent of an angle is opposite over adjacent. So if you like that one, you can use it. If you like SOHCAHTOA, keep spelling SOHCAHTOA correctly. SOHCAHTOA. So anyway, sine of W. Go from W, and if you're looking that way, opposite over adjacent. Oh, wait a minute. Opposite over, I'm trying to do the sine. Opposite leg to the W would be the 4. And the hypotenuse is the 5. We hadn't used the hypotenuse yet. Maybe you want to label that that's the hypotenuse. The cosine of W, well, I guess I can, since I'm doing all W, I'm going to go ahead and label this one opposite, this one adjacent to the angle. Cosine will be adjacent leg over hypotenuse, 3/5, and the tangent will be 4/3. Okay, now the next problem, though, does say to do the sine of t, cosine t, and tan t from the same figure. So I'm going to change colors because now things have changed. If that's where I'm coming from, then now this is your opposite and this is your adjacent. It just changed. The hypotenuse didn't change. So the sine of t, sorry, it is on the next page, isn't it? You know what I'll do? Let's just draw this up here. Now we're coming from T. This was W, and on the picture, make sure I got things right. This was an R, and then it was 3, 4, 5. A 3, 4, 5 right triangle. Okay, now we're coming from angle T. Okay, opposite will be the 3 then, adjacent will be the 4, and the hypotenuse is still the hypotenuse. So sine opposite over hypotenuse is 3/5, cosine 4/5, and the tangent 3/4. Good. Okay, now all three ratios are needed because the clues in some problems vary. So sometimes you're given clues about the legs only, so then you use the tangent. Sometimes you're given questions that concern the hypotenuse, then you would use the sine or the cosine. So we're going to write a trig equation for each. These are telling you which one to use. So this one's going to be the tangent of 27. You come from the 27 and identify which is opposite, which would be the x, and the 20 is adjacent. Now, it didn't say to, oh, it did say to solve it. So, of course, we're going to do cross products. X is 20 times the tangent of 27. And that calculates to, I forgot, was it 27 degrees? Thanks. 10.19, what does it say to go to? It didn't say. 10.2, that's fine with me if you just do the 10th. This one says to use the cosine, and why? Well, you can see that the 60 is included between the hypotenuse and the adjacent leg to the 60. That's cosine. So cosine of 60 is equal to 8 over x. Now, this one's going to give you x times the cosine of 60 equals 8. You will need to divide 8 by the cosine of 60. So 8 divided by cosine 60, bless you, you're welcome, is equal to 16. The next one is the sine, because you have the hypotenuse and you have the opposite leg to the angle that's 13 degrees. So coming from that angle, sine of 13 is equal to x over 50. All right, and so we'll just do x is 50 times the sine of 13. And you don't have to write that step if you don't want to. But it is helpful for me to see what you're doing and what you're typing. If you write more steps, I can see or fix if you're doing something wrong. 11.2 for that one. And I don't have any labels, so I'll just leave them without units on them right now. Okay, let me know if I'm going too fast for you. Number 26 is tangent, and that's because x is on the leg opposite the 40, and you're given the adjacent leg. So tan 40, x over 14. So we'll type 14 tan 40 to find x. You're probably faster than me anyway. 11.7. And 27 is the sine, so the sine of 28, that's because the leg opposite is given and the hypotenuse we're trying to find. So that would be 10 over x. So x times the sine of 28 equals 10. You've got to remember that now you have to divide. 10 divided by sine 28. .3. And finally the cosine, and the reason it's the cosine is because next to that 30 is the adjacent leg and the hypotenuse is got 200 on it. So we'll do cosine 30 is x over 200. Okay, so we'll do 200 times the cosine of 30 on our calc. And we should be getting 173.2. Okay, that puts us at 28, so we're at the bottom of 2A. Use whatever ratio you choose to solve the following to the nearest 10. Okay, so I'd like you guys to set these up for me. I'll take volunteers for them. Someone tell me what to do for 29. I just want to be checking for... Guys, someone will tell me what to do for 29. Tangent of 32 equals... You need to have an equal sign in your equation. It should never not have one. It should be, say, equals. Next, you can calculate the 75 tangent of 32. And you should be getting, I didn't write it down. What is it? 46.9. Thank you. And that would be labeled now in meters, please. Okay, someone want to set up number 30. Sine, cosine, or tangent? Sine, Ellen? Okay. Sine of, tell me what to write. Thanks. Great. Now we'll do it. So we're going to calculate 86 times the sine of 15. Want to finish that? Meters. Thank you. Okay. 31. Another volunteer? Someone different? I'm not going to keep asking the same people, and I'll just call on you then if you haven't. Okay, go, Logan. All right. Okay, so its cosine is adjacent over hypotenuse. Which one's the hypotenuse? You see how you flipped it? That's good. That's what I'm checking on right now, why I'm asking you guys some questions. So that's good. So your hypotenuse has to be on the bottom. So it should be x over 74. Good. All right, now finish that one off. You guys agree with 64.1 then? All right. 32, please. Okay, I'm going to set it up. Okay, you chose the sine because opposite, trying to find the hypotenuse. Good, that is correct. So it's going to be 28 over x, you said, right? All right, that's the kind now. So let's see if we calculate this one correctly, because x is going to be 28 divided by the sine of 39, not multiplied. What'd you get, Kay? Didn't do it yet? Okay. But that's what I need to know if we're going to calculate. Sometimes you even set them up correctly, but you won't type them right in the calculators. That's what I want to know. 40 what? 44.5, good? All right. Any questions about that one? No? All right. Now, there's a little problem with number 33. There's no place where they put an X on it. So, since that's a cosine, that's a sine, let's just stick it over here. All right, so this would be tangent. All right, I'll just say it. Tangent of 56 is x over 60. All right, and then what'd you get for that, Addison? 89.0? I'm not verifying. I did not type it on my calculator, so you got that too. Okay. All right, and last number 34 on the page. You already did when did make him. Good. Yes, it is 52 over x. Now, how do you calculate it? There you go. You got how big? 55.3 meters. Thank you. Okay, I'd like you to continue, please. Now, I'm going to skip this section right now to make sure I get to the angles, okay? So let's jump down to the bottom of the page for a moment, and we can go back to these. How many of you already finished these anyway? Anyone? Okay, cool. Some of you are definitely ahead on that. All right, so let's refresh on how do you find the angle measures. So sometimes instead of finding sides, we're trying to find an angle measure. And your calculator, again, if a right triangle has two sides of known length and it has no angles other than the 90, it has to be a 90, that are known. We can still use the same trig ratios to find missing angles. When looking for missing angles, you're using the inverse buttons. Those are above the other buttons. So on the calc, you'll see that above the sine, there's one that looks like this. And under the cosine, there's one that looks like this. Okay, and under the tangent, you get it, right? So you're going to use the second key, and then you're going to press in sine, cosine, tangent, whatever you're using. So if I want to know this, what this angle, what ratio provides me with this angle, remember this is a comparison of the opposite to the hypotenuse, and it's 64%. The opposite leg is 64% of the hypotenuse. You're going to need to hit second sine of 0.6427. So you go in your calc, you hit second sine 0.6427. You hit enter, and it will give you back the angle. Now, we're going to round, it says to the nearest whole number. I really don't like that. So I would rather you went to the 10th. If we went to the 10th, this would round to 40. Change that to 10th, please. I don't know, it bugs me, because that, I don't even think that doesn't even fit the sig fig rules. Not that I'm going to go by sig fig rules or anything. I used to talk about that, well, when I taught trig, but in pre-calculus. But anyway, this would, I just said 40, right? I'm forgetting my angle measure by now. All right, hit second sine, 0.99756. Okay, and that would also round to 86 degrees, a whole degree. And I think it's just the last one doesn't. Second tan, 1.6003. Okay, 58 degrees. And then you do put in the fraction. You hit second cosine, 24/25. (16.3 degrees if you go to the 10th. Okay, we need to find the missing angle where the question mark is. I'm going to write it using the angle letter when I'm doing it. So, if you were standing at angle A and you looked across, this would be the opposite leg, this would be the adjacent leg, if you want like labeling those. So, the tangent of A, opposite and adjacent, 36/40. Now you go to your calculator and you will type in second tangent, it'll look like this, and you'll put in 36 divided by 40. So there's not been many times when I haven't shown you how to do things without a calculator, but this is one of them. We need the calculator for this. 42 degrees. To the nearest tenth, that would be 42 degrees. So angle A is 42 degrees. You should be putting degrees on your answer. It's no longer a length. Okay, if I want to find angle B here, then I need to look at what I've got. I've got the hypotenuse, so I'm going to use sine or cosine. And then I notice that the leg right next to angle B is the adjacent leg, so that's going to be cosine. So the cosine angle B is equal to 28/31. So you hit second cosine, 28 divided by 31. 25.4 degrees. I am again changing the whole degree thing to 10th. I just don't like chopping off parts of my angles. Okay, but actually sig figs it would have been to the whole degree if we were actually doing real sig figs. But I'm not doing that. Is anybody taking a class with sig figs? Okay. In what class, Kim? In Chem, okay. You know what I'm talking about then. If you're doing angles, it is just two places because these are whole numbers at 2 decimal places, right? So the angles are to the nearest degree. Oh yeah, 30 is only one sig fig, so yeah, we're not doing it. No. Okay, well then I'll put one there because math does not agree with those science rules. It doesn't. Sorry, it doesn't. General math. But I shouldn't say things like that. Let's leave it at that. We're not worrying about our sig fig rules. Okay, so this would be the opposite over hypotenuse should be the sine. Sine of C is 30 over 37. And the science teachers probably wish we would teach it. Like I said, that's a little bit later on. We need to worry about that. Second sine 30 divided by 37. Yeah. Yep. I should take that out. 54. It's hiding. It's 54.2 degrees. Yeah, I found that out the hard way before. I literally kept on. I didn't know it was still going because it wasn't showing, and it was. And I thought I didn't have my lesson recorded, but I did. And I also had another hour after class with students in the room. That's kind of funny. I just deleted it. I think I'll have to delete some of this one. Okay, this is your homework. So we've got some minutes if you want to flip to. You're doing worksheet. I'm assigning worksheet 3 and 4. 4 has got a bunch of word problems on it, but a lot of the pictures are already drawn for you. There are some where you do have to draw the pictures. And I will help if you have any that you feel like you need to go over or help with. So tell me. Oh, there's a little star on number 7. Any clues as to why? What's got? Well, there might be another way to do it. About 2,000 years ago, someone developed something that probably would be more efficient. It's okay. It's just Pythagorean theorem. So, huh? He's just making it hard for himself, making all that extra work. All right, Pythagorean theorem for that one, guys. I don't know. If you see a word problem you'd like me to do, I'd be happy to do one if you would like. Do this one? Okay. Mary is flying a kite. I would think it would look something like that if Mary was out there in her field. Now, the string is making the kite's on a 50-meter string. And it's making a 50-degree angle with the ground. Oh, wait a minute. So Mary is lying down. Sorry, couldn't help it. All right, and she got the string in her teeth. Okay, so now this is 50 meters, and the angle with the ground is 50. Okay, how high above the ground is the kite? So, let's give her a little blanket. Okay, anyway. In the park. Little animals, I don't know. Okay, I've gone overboard. What is this, what's the setup anyway? There you go. I just used H for height, doesn't matter. Oh, no. Somebody pick another one? I just want to change this to beach. Seagulls. Which one? 14. From the top of a lighthouse, the angle of depression to a buoy. Okay, so buoys are out in the water, and you got a lighthouse. Okay, so the angle of depression always comes off a horizontal line. So that would be your angle of depression, 25. Now, angles of depression are equal to angles of alternate interior angles theorem. So that'd be 15. All right, that'd be 25. If the top of the lighthouse is 150 feet above sea level, that's 150. Find the distance from the buoy to the foot of the lighthouse. This is the lighthouse's foot, so I put a shoe there. Okay. There. Sense of humor. Yes. That would be tangent, guys. What's that? Oh, Haley. Pops. I gotta try to. Oh, screencast-o-matic. See?